Hello everyone, my name is Arya Chavushi. I'm a second year PhD student at the Department of Civil Engineering. Today I want to talk about my project about a deep reinforcement learning framework for hurricane trajectory prediction. Hurricanes are a type of natural disasters that cause a lot of economic and social damages. One of the famous examples of hurricanes was Hurricane Harvey, which penetrated inland and stalled over the Texas region for several days, causing over $155 billion economic and social damages. However, predicting the trajectory of hurricanes is very challenging due to their complex behavior and unpredictability. So, numerical weather predictions historically have attempted to predict hurricane trajectories. As we can see in the left figure, over the years, these numerical weather prediction models have improved, but they still lack accuracy in predicting the trajectory. Recently, AI-based models have emerged for predicting hurricane trajectories, and the right figure shows us the comparison of two different models, one National Weather Service numerical based model and the other one Windborne Weather Mesh, which is an AI model. And we can see that AI based models have a higher accuracy in predicting the hurricane track. How can we use reinforcement learning for hurricane trajectory prediction? So here in the red line shows the actual path of a hurricane, and the blue line shows the predicted path from the reinforcement learning. So at time step t, the centroid of the hurricane is considered as an agent, and the state of this agent is a 4 by 50 by 50 pixels tensor, which consists of its current meteorological environment at the proximity of that location. And this state tensor goes into a convolutional neural network, which gives us an action, and the action tells the agent how far should it move to the left or right or north or south. And a reward is assigned to the agent based on how closer it gets to the next state from the actual track compared to how far it was before taking that action. Here we used advantage actor critic algorithm for solving the problem. We had 91 hurricane tracks with 10 total time steps, and we used two separate convolutional neural networks for policy and value networks. And also I used PyTorch for parallelization, and we trained it on Apple MPS chips, and we gave inputs as batches of 20 images. So the advantage actor critic algorithm optimizes the policy and value network parameters to maximize the probability of the actions taken with regards to their advantage. In order to measure the performance of the algorithm, we plotted total return and critic loss with respect to episode number. We can see that until episode 170, total return saw a slight increase, which shows that the policy is improving. However, after episode 170, total return decreased significantly, which shows numerical instability. And my speculation here is that due to one single bad step, the policy did not improve and saw a very significant decrease in its performance. At the same time, we can see that the critic loss did not see any significant changes over the episodes. For future works, the first step that I should take is to change the reward calculation. The next step would be employing proximal policy optimization or trust region policy optimization in order to prevent the policy network parameters to update very largely and steeply. The next thing would be changing the environment variable to better represent the current environment that the agent is interacting with. The fourth work would be changing the policy and value networks, deep convolutional neural networks architectures. And finally, testing the value-based methods including deep Q learning.